Hello class, and welcome to lesson 6.4b, switching forms to vertex form. And today we're going to use two different methods. We're going to use the factoring method and the partially factoring method. So last day we learned method 1, which was completing the square, and today we're going to learn two other methods, which is the fully factoring method or the partial factoring method. So please, ladies and gentlemen, before we get into that, we're going to take a look at some warm-ups. Now some of this warm-up is going to be new stuff and some of it's going to be old stuff. So folks, I want you to think back to last unit, and it says, recall, ladies and gentlemen, if we know two roots or two solutions of a quadratic, okay, we can easily find the axis of symmetry. So in the past, we might have a quadratic that looks like this, okay, for example. And if we found the two roots, we found the zeros, okay. Notice, ladies and gentlemen, that halfway between there is the axis of symmetry. So what we can easily do is we can find the axis of symmetry, and this is true for all symmetry points. So maybe when I found the height equals 5, you found these 2 points, and you would add them up and divide by 2. So here's your new rule. You just take your solution, add them up, and divide by 2. Okay, so from factored form, ladies and gentlemen, once we factor it, we have our two roots, S and T. So this would be S, this would be T. Doesn't really matter which one's which. As long as you add them up and divide by 2, you can find the axis of symmetry. Remember that also equals your p-value of the vertex, okay? Okay, so that's where we're heading today with one of our methods. Okay, so to warm up, to get us ready, let's take a look at this example. It says find the axis of symmetry for each of the following. So I know I've got zeros at 3 and 8, and they're already solved. So you're going to go x equals s plus t, so 3 plus 8, and total them up first, and then divide by 2. Plug in your calculator, and you're going to get x equals 5.5. So that's the axis of symmetry, which is also the p-value of your vertex. Second one says we've got x-intercepts. Hey, those are the same as 0, so we're already solved. So it's going to be x equals negative 3 plus 6 divided by 2. Plug in your calculator, x equals 3 over 2, or x equals 1.5. Sometimes when you're trying to visualize the axis of symmetry and you draw a line, you need to know exactly where where it is, and it's at 1.5. Okay, I would accept either answer there. But to graph it, you might want to stick with the decimal answer. All right, C is a different example, ladies and gentlemen. C, we don't have things solved, but we do have things factored. So if we know x minus 4 equals 0, okay, we can solve for x, so x equals 4. There's one solution. The other one is x plus 6 equals 0. Move the positive 6 over to solve, and you've got x equals negative 6. So to find the axis of symmetry, you add those two up. So 4 minus, well, plus negative 6, which is negative, is a positive, times a negative becomes a negative. Okay. So simplify that, folks, and you're going to get x equals negative 1. All right, there's the first 3 examples done. Now let's take a look at number 4. So number 4 is in factored form, ladies and gentlemen. So, but we haven't solved it yet. So we've got to solve it to find the roots, okay, or the solutions, or the zeros. So the first factor is negative 2x. That's got to equal 0. Well, to get x by itself, you divide both sides by negative 2. So x equals 0. One solution there. The second solution is what's the other bracket, or the other factor. X plus 7 equals 0. So x equals negative 7. There's your second factor. So to find the axis, you go x equals 0 minus 7 divided by 2. X equals negative 3.5. Again, the axis of symmetry, guys, is a vertical line that goes through the vertex and makes a symmetry to the left side and the right side of the parabola. Okay, last question, ladies and gentlemen, taking a look here. This is standard form, and we want to put it into factored form. Okay, so the first thing we want to do is common factor out a negative 2. So we're going to take a negative 2 out. So we've got x squared minus 6x plus 8. Okay, now look inside our brackets, folks. We can still do some factoring in here. Okay, again, you notice the trinomial, so you're going to say product equals 8, sum equals -6. Hopefully you've mastered this by now, and you should know your factors of -2 times -4. And because it's simple trinomial, you can sub them right in. There's no decomposition needed here. Okay, ladies and gentlemen, now we go to solve this. Okay, in order to do this, we got to find the x-intercepts. We let y equals 0. Okay, so if y equals 0, we have to realize, how do we get the left side? If the left side equals 0, how do we get the right side equal to 0? Now -2, it's a fixed term. It does not change. So you ignore it because we can't sub anything in to get it to equal 0 because it's already fixed. It's a constant number. But each bracket we can, so we're going to let x minus 2 equals 0. Solve that, x equals 2. Okay, or the other bracket, x minus 4 equals 0. So x equals 4. Again, the -2 can never change to 0 because it's not a variable term. So you just ignore the constant terms, okay? All right. Now we take a look, folks. We've got our solutions here, or our roots. Now we're going to add them up and divide by 2 to find the axis of symmetry. Okay. So x equals 3. Awesome. Now we're going to use that to apply it to our second method, which is when it is fully factored. So let's take a look, folks. So again, we're switching forms from vertex to vertex form using factored or partial factoring. So method 2, it's when it can be fully factored. Okay. Underline fully factored. Okay, because we know we used quadratic form when we couldn't fully factor things, or we had a decimal answer, right? These are just for whole answers. Okay, so here's our steps. Number 1, find the zeros by factoring. Okay, so that's something we should have mastered in Unit 5. Next, it says to find the vertex by doing the axis of symmetry. So that's the first part. The new part is we're going to sub in our answer, which is our p-value, into the equation and find q. As long as we can identify A, we've got our 3 things to sub into vertex form. Okay, let's do the first one together, and then I'm going to try to see if you can do the second one a little bit more solo. All right, so let's just put it up here so we can see our steps. So step number 1 says to factor. So first step we need to do is to common factor out a -2 out of the, because this term goes by -2. Now folks, you could factor out a 2. However, if you factor out a -2, it's going to be easier for you to factor inside the brackets because you're going to have a equaling +1 here instead of -1. So please take it out so you've got a simple trinomial to factor in the brackets, because that's going to save you some time and heartache. Okay? So factored out to -2, I'm going to then figure out my product and sum. So product equals 12, sum equals -8. What 2 factors do we have there? Hopefully you know it's -2 times -6. So you have x minus 2 times x minus 6. Excuse me, folks, I just sneezed. Apologize for that. Now we're going to, oh, I apologize. Haha, my sneezing got me off task. Now that we've factored, ladies and gentlemen, we now set our factors equal to 0, which are the 2 that are in the 2 variable terms, which is x minus 2 equals 0, which is x equals 2. And you can show me x equals 2 right away, folks, if you already know that. Or x minus 6 equals 0, so x equals 6. Okay, so now we do what we just did in the warm-up, folks. We want to find the axis of symmetry. So to find the axis of symmetry, you add those up and divide by 2. So x in this case is going to equal 4. So what do we know already, folks? So therefore, p equals 4. So we know that part already. Okay, what else do we know? We know a equals what value, folks? -2. So we've got a, we've got p. The only other thing we need to find is q. So to find q, we're going to sub our answer in for our axis of symmetry into the original equation. So you're going to go y equals -2 times 4 squared plus 16 times 4 minus 24. So I spent a bunch of time working on substitution so that when we get to this stage, we've got that substitution mastered. Okay, do some work here. 4 squared is 16 times negative 2 is negative 32. Plus 4 times 16 is 64. Minus 24. And plug in your calculator or use your mental math. Y equals 8. So we find y equals 8. That is q equals 8. Okay, so now we know we can sub a, p, and q in the formula. So we've got a equals negative 2. We've got p equals 4. And recently q equals 8. So now we can sub it in the equation. So y equals a, which is negative 2, x minus p, which is 4 squared plus 8. And now, folks, it's in vertex form. Awesome. Okay, I'd like you to try following the same steps to do the second example by yourself. So pause. Okay, welcome back. Hopefully you've tried this independently. Step 1, ladies and gentlemen, of factoring is to common factor out of 3. So you should have x squared plus 5x plus 6. Okay. Now I need to take a look at factoring within the trinomial. So hopefully you had a product equaling 6, a sum equaling 5. You should have 2 times 3 there, folks. So you should have 3. X plus 2 times x plus 3. Solve each bracket, ladies and gentlemen. And again, if you know these right away, you can just go x equals negative 2 and x equals negative 3. Okay, or you could write down zeros or negative 2 and negative 3. Now you're going to find the axis of symmetry. Okay, so it's negative 2 minus 3, all divided by 2. Okay, so x equals negative 2.5. Just to back up there, guys, that means p equals negative 2.5. What else do we know, folks? A equals 3 from standard form. Okay, now to find q, you've got to sub in your value of x equals negative 2.5 into the equation. So you go y equals 3 times negative 2.5 squared. You're definitely going to need your calculator for this one, guys. Plus 15 times negative 2.5 plus 18. Okay, plug it in your calculator. You've got 18.75 minus 37.5 plus 18. Okay, so y equals negative 0.75. Okay, last step, and that's your q. Okay, so then you state all your values that we need to sub in. So a equals 3, p equals negative 2.5, and q equals, in this case, folks, negative 0.75. Sub it all into your equation. Y equals 3 bracket x. When you subtract a negative, folks, that becomes a positive 2.5 squared minus 0.75. Okay? So there is method 2, ladies and gentlemen. That's when you can fully factor it. Okay, so a visual for that, folks. It's fully factored. Doesn't matter if the parabola is opening up or down. Okay, so let's pretend it's opening up. Okay, so for fully factoring, we're going to factor and find our zeros. Then you're going to add them up, divide by 2 to get the axis of symmetry. And once we know one point of that, we sub it in to find the other point to give us our vertex. And then we sub it into vertex form. Okay, so that is method 2. Now, method 3 is a little bit different. It's a partial factoring method. Okay, and the key is here, folks, the big difference we're going to do here is we're going to let c equal the constant value. Sorry, we're going to let y equal the constant value. So I'm just going to do a visual up here, actually over here, ladies and gentlemen. If I take a look at a parabola, and say it opens up like this, and opens up like this. If we could use the fully factored method, guys, we'd be taking these two, adding them and divided by 2. But that's not the case, so I'm going to erase that. Okay? What we're doing, folks, is we're going to say, hey, y equals the c value. So we're going to be looking at these two values. And again, they're two symmetry points, so we're going to be adding them up, dividing them by 2 to give us the axis of symmetry, and then we're going to be the same thing. Sub in the x value of your vertex to find your y. Okay? The reason why is because you can't fully factor this, or it would take a long time to do decomposition and stuff. So we don't want it to go that way. So the only thing I want you to fix here, folks, in the question is to find the vertex by converting to vertex form. Okay, because you could just graph it and find it. So that's why I wanted to add that to the question. All right, so here's our steps, folks. The first step we want to remember is that we're let y equals the constant value. So instead of finding the zeros, we're finding 2 points of intersection, right? Okay, we're going to sub them in. Once you got your 2 points, you're going to find the axis of symmetry. You can find those 2 sim points. Then you're going to sub those 2 into the axis of symmetry to find the vertex by doing the same thing, finding the axis, subbing that value into the equation, and noting A. So 2/3 of this is the same as the last method. The only thing that's different is kind of like the first 2 steps. Now, step 1, which is completely different, is your common factoring out of the first 2 terms. Okay? All right, and you can actually switch order 1 and 2 around. It doesn't really matter to me. But let's do it the way it says for number 1, and I'll show you number 2, how you can switch it the other way. Okay, so taking a look at step number 1, common factor the first 2 terms. Now what's different here, folks, is you're factoring completely. So you're looking for a common x. So you would say 4x is common factor. Okay, so you're going to be left with x minus 2 and then plus 7. Okay. Now, ladies and gentlemen, it says let y equal c. Therefore, we're going to let y equal 7. So wherever I see a y, I'm going to put a 7. So 7 equals 4x times x minus 2 plus 7. Now, if we've got a 7 on the left side and a 7 on the right side, what do you think happens to those? Ha ha! They will cancel out. So if you bring this 7 over, it becomes negative to the other side. They're going to cancel each other out. Why do we do that? Because then we got 0 equals our 2 factors. That's going to make sense, folks. One of our factors will always be equal to 0, which is this first one, because 4x equals 0. How do you get x by itself? Divide both sides by 4, so x equals 0. Okay, and the other one, x minus 2 equals 0, so x equals 2. Okay, so that's going to be this one, for example. All right, now we've got 2 sim points, but these are not zeros, okay? These are points of intersection. So let's just write that in. Note, these are not x-intercepts. They are P of i's, meaning point of intersections. Give me a second, folks. I've got to make some more room. I apologize. I hope you're having a great day. Let's just allow us to have a little musical interlude. Do 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 do. Yes, your teacher's crazy. Do 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 do. I just need to make some more room. All right. Thanks for your patience. Okay, but still, folks, we're back on track here. These are not zeros, but they're still point of intersections, which means they're still symmetry points. So you can still find the axis of symmetry by adding them up and dividing by 2. So x equals 0 plus 2 divided by 2. So you're going to get x equals 1. What does that tell us, folks? That tells us that p equals 1. Okay. Taking a look, we can sub that value into the equation so we can find the y part of the vertex. Oopsie, sorry. So wherever we see an x, we're putting a 1. Okay. So we've got y equals 4 minus 8 plus 7. So y equals 3. So that tells us our q equals 3. Okay. And if we know that, folks, we've got A, P, and Q. We forgot that A equals 4 from our vertex form. So then we can, or from standard form, my fault. Now we can sub it in. So, therefore, So I'll just do since A equals 4, P equals 1, and Q equals 3, therefore, let's sub it in the equation. We've got y equals A, which is 4, times x minus p, which is 1, squared plus 3. Okay, so again, partial factoring, I want you to remember that you're finding 2 points of intersection, not a symmetry. It's kind of like when you subbed in for the rocket. When was the rocket at 10 meters or 200 meters? You subbed it in and you found 2 values, which are point of intersections, but they are still symmetry points, so you can still apply that. All right, let's try example 2 by switching step 1 and 2. So I'm just going to say let y equal negative 24 to start with. So I've got negative 24 equals negative 2x squared plus 16x minus 24. What's going to happen to those negative 24s? They're going to cancel. So I've got 0 equals, I apologize, I forgot my x in there, ladies and gentlemen. Can you throw an x right there? Thank you. All right, now what we're going to do, folks, is common factor on the right side. Okay, so we've got negative 2x we're going to take out, and then we're going to be left with x, watch your sign, minus 8. Notice that might be a little easier for you guys because you're just factoring what's left over. So that might be a method that you might choose. Okay, apologize for the interruption here, guys. Just give me a second. Okay, so folks, if we're trying to visualize this, we know our y-intercept is negative 24. Okay, it's shooting up. We're not sure. But I think it's going to come up over the x. So there's our quadratic, right? Okay, we're subbing in y equals negative 24. So we're going to find these 2 intersection points. Okay. So we automatically know this one is x equals 0, okay? And this one is x equals 8 if you solve it. So that's the second one here. Find the axis of symmetry. So x equals 0 plus 8 divided by 2. So x equals 4. What does that mean, folks? When I draw my axis of symmetry down, I know it's hitting 4 on the x-axis. And I know one part of my vertex, so then I sub it into the equation to find the other. So you're going to go y equals negative 2 times 4 squared plus 16 times 4 minus 24. Y equals 8. Okay, so what do we know? We know A equals, from up above in standard form, negative 2. We know P equals 4 from our axis of symmetry, and we know Q equals 8 from solving it just above. So therefore, y equals A, which is negative 2, times x minus P, which is 4, squared plus 8. And there you go, ladies and gentlemen. So the handout for homework, folks, should be that foolscap one. It should be folded kind of in half. Doesn't fit regularly in your book. You should see it should have holes on the side. Anyway, see your handout, ladies and gentlemen. Do just questions B, D, and F for all. And have a great day. If you need any help, obviously come and see me for help. Thank you and goodbye.